Recitation problem 3. Vector A has a magnitude of 12.3 units and points due west. Vector B points due north, but we don't know what the magnitude for B is. Question A. What is the magnitude of B if the vector A plus B has a magnitude of 15 units? Alright. This is a simple case, by the way, because the two vectors are perpendicular. One lined up with the x, another one is lined up with the y. Alright, let's assume that the a plus b vector is represented by r. r equals a plus b. Let's figure out where is that vector r. We're going to use the tip-tail method. Look at the vector B is lined up along the y. I'm going to slide it over so that its tail is going to coincide with the tip of vector A. Here is the vector B. The vector R is that one that starts at the tail of A and ends up at the tip of B. Here is R. Clearly, vector A, B, and R in this simple case, they form a right triangle where the angle 90 degrees is right here. Using the simple Pythagorean theorem here, we should be able to solve for whatever we need. Alright, let's try that one. The r squared equals a squared plus b squared. Notice that these now are magnitudes. The first equation is vectors. This one is all about magnitudes. The vector r, which is a plus b, is given to us. It does equal to, here it says 15, so r equals 15 units. The magnitude of a is also given to us, 12.3 units. A equals 12.3 units. If you know a and r, you should be able to solve for the b by just substituting. Here is 15 squared equals a, which is 12.3, square that one, plus b squared. Here we are. We can easily solve for the b. After you plug in the information into your calculator and solve for the b, you get b equals 8.6 units. Part B is what is the direction of a plus b relative to the west direction. Basically what you need to do here is solve for this angle. That is the angle that will tell us how many degrees the vector r above the west direction. What do we do? Since we know the a and we know the b, the inverse tangent is the way to go. Theta is going to equal inverse tangent opposite, which is the b, over a. We know the magnitude of b, we just solved for it, 8.6. We know the a is 12.3. Put those together and solve for the theta, and the theta is going to equal 34.9 degrees north of west. Part C of the question is, what is the magnitude of b if a minus b has a magnitude of 15 units? I could easily predict what the answer is, but I'm going to repeat the whole thing from scratch so you understand how to deal with vectors. Right, let's make some space here. The question states what is the magnitude of b if the difference between a and b is equal to 15 units. Now it's a difference between two vectors, no longer the sum. Let's call that difference vector r1. r1 is going to equal a minus b. We've been through this before. The difference is the same as the sum of a plus negative b. So I'm going to deal with negative b vector here, okay? Let me show you what is the negative b vector. It's this one in yellow. All you need to do, you reverse the direction of vector b. Now, what do I have? A plus the negative b. Let me move the yellow vector, the negative b, so that its tail is going to match the tip of vector a. Slide it over right here. Here I am now with two vectors a and negative b mounted tail, tip, tail, tip. the R1 is that one that starts at the tail of A and ends up at the tip of negative B. Here is R1, and notice also in this case I have been able to form a right triangle where the angle 90 degrees is right here. And this is due to the fact that A and B are lined up, one of them along the X, one of them along the Y, to solve for R1 or B or A, whatever you need to solve for. Pythagorean is the way to go. And here's how we do that. R1 squared equals A squared plus B squared. Since the R1 is given to us to be 15 units and the A is given to 12.3 units, you can easily solve for the B, and notice that the expression is very similar to before, and therefore the B vector is going to equal 8.6 units also. Solving for the direction of R1 with respect to the west is basically solving for the angle right here, this theta. I'm going to call it again theta. And it's clearly from the diagram is south of west. To evaluate the angle, you need to use the triangle given here. Inverse tangent is the way to go. So the theta equals inverse tan. Which component? The negative B component, right? Divided by the A, solving for the theta here, you're going to get a similar value than before. Theta equals 34.9, but be careful in this case, the orientation is south of west.